Hello everyone, today I'm going to explain how to use voronoi diagram in tNavigator. The voronoi diagram is a method of dividing a 3D property into regions in such a way that the boundary between any two neighboring wells, as seen in the screen, is perpendicular to the straight line connecting the wells and run halfway between these two wells. In the screen you can see the example of voronoi regions, and the voronoi diagrams can be created for all wells or for the wells that selected with the help of a well filter. The uses of voronoi diagrams include a rough estimation of fluid in place in a well's region. Voronoi diagrams are also used to estimate a well's drainage area. To create a voronoi diagrams, first we have to create a new model designer file, and we can name it voronoi tutorial. Then this is the new project window, and we're going to load the initial data by clicking project here and click import data from existing models, and the file name is black oil demo, and we are going to choose the import mode convert schedule section to well rules. Then we have imported the initial data, and we're going to create a new grid properties. In the geometry object, click on the 3D grids and right click on the properties to create a new object named voronoi regions. Then we have a blank grid property as shown in the screen, and then we're going to calculate the voronoi diagram by clicking on the voronoi regions property and clicking on this hammer. There are two ways to calculate a voronoi diagrams by clicking this menu here, auxiliary calculation. We have 3D voronoi regions and multi-layer voronoi regions. The 3D voronoi regions has the formula for distance in calculated in 3D and taking the x, y, and z into account. The distance from a well to blocks is calculated in all three directions. We can try to apply to see the difference between 3D voronoi regions and multi-layer voronoi regions. This is the 3D voronoi regions results, and for the multi-layer voronoi regions, it is built in its grid layer independently from other layers. If a well runs through the blocks with coordinates x1, y1, and g1, but does not run to the block with the same x and y but different g, then in the layer corresponding to the g1 coordinate, the voronoi region is built. But in the other layer corresponding to the other g coordinate, the voronoi region is not built. We can try to apply the multi-layer regions. The difference between them both is the 3D voronoi regions did not cover the part that has no wells in it. Meanwhile, the multi-layer voronoi regions cover all of the area, as seen in this grid. And then next we're going to try the well influence radius in the 3D voronoi regions. If we set the radius to 100, then the radius of voronoi regions from the well is smaller, and it can get bigger if you change the radius here. Yeah. And this radius can be used in both 3D voronoi regions and multi-layer voronoi regions. There is no difference if we use radius in both, as seen in the screen. It's almost the same if the radius is small. And then next we are going to create a well filter. Here we can create a well filter, and then we're going to click on this hammer again. We're going to choose which wells we're going to use. For example, I want to use 36, 50, 48 and 15 well. Apply, close, and we're going to change the well in the voronoi regions. Here we can click on well filter and change the well filter into the one that we created before. And yeah, as seen, the voronoi region changes from so many wells into only 4 regions. And then we are going to calculate the static properties per region. Here we click on, we are going to close this, and we're going to open table and then create new tables. Then we are going to open the table with the hammer logo. So we're going to choose the table from property and choose the grid block black oil demo, and choose the property that we want to create, such as porosity. And then we are going to use mean. This grid property, you're going to choose the voronoi regions and click apply. How to show the table is by clicking this table here and tick on the table 1. This only show the wells that we already create from the filter. If we want to turn off the filter, then we have to change the well filter here, untick the well filter, apply, and then we are going to open the table again and apply, and it can count every porosity from every well. Next, we are going to define custom fluid in place region. First, we are going to open the voronoi regions in 3D. And then we are going to see the statistic of the grid. we can see the voronoi regions only have 15 regions, and we want to add a new regions here, the grid that doesn't have color yet, and we are going to add a new 16 region. First we have to do is click on the voronoi regions, click on the hammer, and open the calculator and click on arithmetics. We have to type if voronoi region is equal to 0, then the region is 16, else we're going to use the basic voronoi regions. We can also click it here so that we don't have to type it, and click and type an if, close. But the grid here hasn't have a color yet, and we're going to color it by right click on the voronoi regions, object settings, then click on palette review, and we're going to add new palette color. Here we can type 16 and by the name 16, and we can choose the color that we desired. Okay, so now we have a new region with the color pink, and then we want to define a custom fluid in place region by clicking case here and open the static, click on the insert new, and we're going to search for fluid in place regions here, and we choose the voronoi regions and click on add, and yes, and close. Here we have voronoi regions on the fluid in place regions. Then we can define a custom fluid in place regions by click on cases, like oil demo, and click on the definition. Here in the dimension we have equal dims, fault dim, rack dims, and tap dims, and we have to make sure the maximum number of fluid in place regions is 16. Here it's only 5, and we have to type it manually to 16. And then we're going to initialize the model. And we have to run the new model. Once we finish the simulation, we can open graphs and click on the black oil demo result 1. We can choose the fipnum here because we didn't change the name to voronoi. Then the fipnum contain the voronoi regions. As seen here, it has 16 regions. With the region 16 doesn't have any wells. We can also compare every regions by clicking shift. And next one, we can create a voronoi regions for dynamic grid. Here, the black oil demo with dynamic model is the dynamic model that created by the initialization previously. And we're going to create a new voronoi regions here by clicking on user properties, create. We are going to name it voronoi dynamic. And we have to fill it in by clicking the hammer again. "3D voronoi regions" and apply. Here is the results and from the voronoi regions after the model has its dynamic models. And we can also calculate the fluid in place per regions by using table. Here we add a new table and then click on the hammer again and create table from property. We're going to choose the dynamic model here for the grid, and the property is going to be oil in place. Here, and the statistic type we're going to use sum. And for the discrete property, we're going to change it into voronoi dynamics here and click apply. The OIP stands for oil in place, and the regions are defined via the set discrete property here, and sum is the property value in the region is the sum of the values in the region blocks. Then we're going to close it, and we can show the fluid in place table per region by clicking here, table, and change it into table 2. Here is the oil in place for every regions that we have. And that's all we are going to learn today, and thank you for paying attention.